Hello, these are the solutions of the algorithms mid-paper conducted in August 2025, where the first question is, you are given an algorithm to find the second largest among array of n numbers, where the given algorithm is not correct. They asked you to give a counter example where the algorithm is not working. Okay, so let us try to understand this algorithm. So the algorithm taking first it assumes that the first element is the largest and second element as the second largest, and then it verifies whether largest is less than second or not. Then in that case it swaps. Now in the first two elements, whichever is the largest, and other one will be considered as the second largest. Now in the remaining n minus 1 elements, if the current element is greater than largest, then update the largest. If it is not greater than largest, then you check whether it is greater than the second largest, then update the second largest. Now what is the problem with this algorithm, and for which inputs that this algorithm works and for which inputs it is not going to work? Now if you clearly observe that it is actually finding second largest correctly if the first two elements contains the largest element. If the first two element contains the largest, then there is no issue, because in the remaining n minus elements, whatever the largest, that will become the second largest. Okay, so what is the counter example? If you consider 10, 20, 30, 40, 10, 20, 30, 40, then what happens is, whenever you are updating the largest, that is 40, you are not changing the second largest value, because second largest will become whatever the previous largest element. Okay, so when this algorithm works, whenever you have the largest in first two elements, it is going to work. That's why whatever the example that they had given, for that it is working. But it is not going to work for the cases where the largest is not in the first two elements. Okay, the correct algorithm is, you just need to add second equal to largest in the first check, because whenever we update the largest, previous largest will become the second largest. This is the second question. Is a part of an algorithm is given, and you have to find out for a particular value of n what is the output of that algorithm, and for general n what is the output of the algorithm, and what is the time complexity of the algorithm. Okay, so when you take n equal to 16, in the first iteration it is true as it is greater than 1, so k will be incremented. Next it will become 8 and k will be incremented, and in the next iteration I value will be 4 and k will be incremented, and the next iteration I is 2, and in the next iteration when I equal to 1 it stops. So k value is 4. Now in the second loop depends on whatever the k value, and in the second loop j is doubled every iteration. J initially starts from 1, and next it will become 2, and next it will become 4, and it stops. So the number of times that the hello world is printed is 2, because for j equal to 1 and j equal to 2. When j is 4, it stops. Now for a general n, how are we going to decide how many times this hello world is printed? For a general n, as we know that initially it is n, and next in the next iteration it is n by 2, in the next iteration it is n by 2 square, in the next iteration it is n by 2 cube, so on. In every iteration k is incremented, so n by 2 power k, when it is equal to 1, it is going to stop. From that k is log n base 2. From that k is log n base 2. Now in every iteration j is doubled, so j initially 1 and j next 2 and next 2 square, 2 cube, some 2 power p. When 2 power p is equal to k, it is going to stop. That means p is log k. P is log k, and as we know that k is log n, so log of log n. So the number of times that the hello world is printed for a general n is log of log n. And the time complexity of this algorithm is the first for loop executes log n times, and the second for loop executes log of log n times, and the log n is the higher order term, so the time complexity is order of log n. Now the next question is on divide and conquer, writing recurrence relation and finding time complexity. So here they had given an algorithm to find sum of n elements of an array by dividing the array into 4 parts. So divide array into 4 equal parts and compute the sum, recursively compute the sum of each part and return the sum of 4 results. The base case is when n is less than n, directly compute the sum. Now if you observe this algorithm, let us suppose the number of operations required for n elements is t of n. Then as we are dividing into 4 equal parts, so each part is of size n by 4, and 4 equal parts, so we will get 4 into t n by 4. And for a division as well as computing a direct sum, we require only a constant time, so that is order of 1. That's why base case is also order of 1. Now if we solve by using a repeated substitution, this method, then we will get t of n as 4 power k t n by 4 power k plus k. Then if you assume that n as 4 power k, then we'll get t of n as order of n, because 4 power log n base 4, so 4 will cancel out and then you will get n, so that is order of n. The time complexity is order of n. Now the next question is sorting by using a divide and conquer. You are given 8 elements, 20, 30, 10, 80, 70, 50, 60, 40, and they are asked you to find a number of comparisons by using merge sort, quick sort, and then compare the number of comparisons. Now what does merge sort does? It splits array into 2 hops and recursively sorts each subarray and then merge those 2 sorted arrays. So first you have 8 elements, it will be divided into 4, 4, and recursively again it will divide into 2, 2, and you have again recursively divided into 1, 1 elements. 1, 1 elements is the base case, they are already in sorted order. Next you have to merge, so 20 and 30 merging require 1 comparison, 10 and 80 merging 1 comparison, similarly 70, 50 and 60, 40, and then you have 20, 30 and then 10, 80, so you require 3 comparisons for merging, and 50, 70 and 40, 60 for merging, again 3 comparisons, and finally for merging these 4 elements requires 7 comparisons. The total number of comparisons required is 17. We are going to get the final sorted array. Similarly, the quick sort, what you do is you pick a pivot element and then place it in a correct position such that all elements left side are less than and all elements right side are greater than that element, and recursively apply this process on the 2 subarrays that we got, the left side subarray and the right side subarray. So here we are using the first element as a pivot. So first, if you consider the pivot as 20, then it partition, so it requires 7 number of comparisons and it moves into the correct position. All elements which are less than, you have only 10, and all elements which are greater than will be in the other side, that is 30, 80, 70, 50, 60, 40, and then we have to partition these 2 arrays, and then we will be picking 30 as a pivot, and when you pick 30 as a pivot, it will divide into left side an empty one, and the right side we have this 80, 70, 50, 60, 40, because no elements less than 30 is there. So if you follow this process, then we are going to get the number of comparisons as 21. Now this is a case where, because the elements are almost already in sorted order, that's why quicksort requires more number of comparisons. Merge sort requires 17 and quicksort requires 21 comparisons. Because the partitioning is not equally dividing the given elements. That is the reason we have more number of comparisons for a quicksort. And the next question is on the greedy design problem. It is similar to the knapsack problem. You are given an exam with the T minutes. There are n questions. Each question requires Ti minutes, and if you attempt or if you spend Ti minutes, you are going to get Mi marks. If you solve partially, then or if you spend the time partially, then you are going to get the partial marks. Now you have a greedy strategy, so it is similar to the knapsack problem, fractional knapsack problem. Select the one which yield most marks per unit time. This is something that you can verify it. And so the question 5 will be attempted first, because it has this per unit time. You have almost 6 marks for every unit time, or for every minute, you can say. So that's and you are going to get the final value as 553.33 for that example. This is something that you can verify. And the last question is on finding the minimum spanning tree. Either you can use a Prim's or a Kruskal algorithm. So you have here cos 2, 4, which is given as x. Now the question is, what is the smallest value which is not a part of the minimum spanning tree? Now if you observe this 4 has only 2 edges, 2 to 4 and 5 to 4. If you want, so as a minimum spanning tree should contain all the nodes. If 4 should be part of the spanning tree, then either 2, 4 or 5, 4 should be there. Now if 2, 4 should be part of the spanning tree, then it should be less than 15, otherwise it should be greater than 15. So what is the smallest value for which it is not a part? Then that is 16. What is the smallest it should be part is 14. And I think there was a mistake in the question part, that is you get only one minimum spanning tree. That is not correct, because at 1, 2 and 1, 3 itself we have 2 choices. So you will get 2 minimum spanning trees. So ignore this part that you have only one minimum spanning tree. And for the third question, you should consider it as 1, answer as 1, or you can also give 15. Both are correct.